We painted a picture, OGA, agent mesh, all of that is fantastic. But the bigger problem is, can the organizations trust these agents today and go live? This is a much bigger issue. And how do these organizations, how do we make agents trustworthy and go live, which is where the whole guardrails point of view comes into picture. And there are some fantastic third-party platforms, Guardrails AI, Nvidia Guardrails, Nemo Guardrails, LlamaGuard from Meta Llama. All these are fantastic guardrail platforms. I think the one that who all the one that started all was I think True Lens by True Era, and they got acquired by Snowflake long back. But guardrails are the ones which kind of makes the whole agent trustworthy. They are like the police in a city, right? So you know that it's safe and you can live in a neighborhood. And if without the police, often there are very rare cases that the whole neighborhood or the city has civic sense and they work very really well. But otherwise, you need the law enforcement to be around, and that is what guardrails literally are from an analogy perspective. And guardrails, we'll have a very detailed session on, I think, day 4, just around guardrails, because when you think about agent architecting in an enterprise setting, these are very important. But on a high level, what you need to understand is guardrails reduce the imperfections that large language models have. And guardrails cannot be applied to the large language model itself. Some of them are, like prompt injection, etc. Like now, LLMs are very aware of how to handle prompt injection. I don't know if you know this example. A few months back, Air Canada had an issue with their chatbot. Someone was able to trick the LLM or the chat agent, and they were able to get, I think, close to $50,000 in refund. I'm not sure about the number, but it was something around that. They had they had a lot of sentiment. I mean, I think the person claimed some issue with their grandmother's health or something of that sort. But long story short, they were able to trick the system and get the, I would say, the response out, which is what prompt injection is all about. But now the large language models have gotten better at it. They're able to handle it really well. But when it comes to other aspects like PII data, toxicity controller, etc., they don't behave that well because they are very general purpose large language models, which is where guardrails can be applied at an agent level. I'll again show you with a simple example. It is always easier to relate when we have an example. So in Lyzr, we have responsible AI as a standalone module as well. So even if you're building on LangGraph, you can actually build the responsible AI policy on Lyzr and integrate the policy via an API. So we are very, very modular and interoperable that way. But let me show you an example, right? These are various modules that Lyzr provides today, like toxicity, prompt injection, secret management, etc. And I'm going to test it here. Say, I am going to burn the city down. So there is toxicity detected. You saw the confidence is 90.14, which exceeds the threshold of 80%. And it's toxic, it's true. And prompt injection is not detected because they're not trying to trick the system, but they're trying to kind of send a hate speech kind of thing, a toxicity into the picture. So the agent detects it and it automatically stops from executing it further. As you see here, when a toxicity check is detected, the agent automatically stops it from moving forward to an LLM. And all the safe and responsible AI, at least in Lyzr scenario, or deep learning, are powered by deep learning algorithms. So it's far more reliable compared to just using another prompt that you may be building on in a LangGraph scenario if you're not using third-party guardrails. So that is how the safe and responsible AI aspects come into picture, making the agents far more trustworthy and reliable for you to deploy them in production.